This is the introduction to experiment 1. Get this going. Experiment 1 is essentially, you'll see a couple experiments there. We're going to do the Fibonacci generator, which I believe is assignment A. So the issue is, it's going to generate a Fibonacci sequence. So the Fibonacci sequence is sitting right here. What you want to do is generate the first 16 values in that sequence. So here's the first 6, I guess. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, etc., etc. What you want to do is generate these using your hardware. After essentially a button press, someone presses a button and it goes through and generates these, and then it continually displays them on the 7-segment display. So the 7-segment display driver is given to you. What you need to do is generate these values. So generally what you're going to do is generate these values and put it in RAM, and you're going to step through that RAM displaying one value at a time at some reasonable rate so you can see it, and that's the entire experiment. So essentially generate Fibonacci sequence and put it in RAM and display it. So a couple constraints here is I only want you to use standard digital modules, and so nothing fancy. You're not going to have to do any major amount of work here. Essentially drop the modules down, connect them, and I'll talk about that later. Don't put any fancy mathematical operators in your circuit. All you need is ripple carry adders. Ripple carry adders, a standard circuit, it's provided for you. And what else? So this is going to need a state machine in it, and I don't want any more than 10 states in that state machine. Actually, you can do it in quite a bit fewer, like 4 or 5. And the state machine should be 100% independent of the size of the RAM, meaning that if I asked you to suddenly generate a 32-bit sequence, Fibonacci sequence, you could use the same state machine. And lastly here, no memory in your state machine other than the state variables. So the Canvas has a ton of resources out there, all the standard hardware modules. There's muxes, registers, and counters. There's that generic N by M RAM that we talked about in the last set of lectures here. There's an FSM cheat sheet or a template. You can work off the template as a starting point. You don't have to write it from scratch. And certainly there's a generic module, which is the 7-segment display module. You don't have to write that. Now, there's issues with the 7-segment display module. I know previous teachers used this, but they used a cut down version. Everything I know about this module is written in the header of the module. I did that purposely. Check it out. So anytime you're designing circuits like this, by all means, you should take this approach. So first, understand the problem. Fairly simple. It's generate a Fibonacci sequence and put it in a RAM. What we want to do is select the various modules for that circuit, connect those modules together, and control that circuit with an FSM. So essentially the FSM is going to be reading the status signals in the circuit and sending out the appropriate control signals to the various modules in the circuit. Once you have it all designed, implement in hardware. So this approach you should take, understand the problem, of course, but design it on paper, and you don't have to be fancy. Keep it simple. Simple designs have a little bit more hardware, but they're easier to implement, easier to debug. And certainly the design process is an iterative process, meaning that you're allowed to make mistakes and go back and correct those mistakes. It's to be expected. That's part of digital design. So you should model your design with Verilog, of course, top level, and drop all the modules down and test on the Basis 3 board. Yeah, anyway, along the way, ask a lot of questions, send me diagrams, help me get you started on this thing. Don't go without getting your questions answered. If you don't know where to start, let me help you on this thing. So keep in mind, you don't have to really write any new modules for it. You can just grab all the modules that exist there. You do have to instantiate them, and when you instantiate them, you have to give your own parameters to it. Don't go to the default models and change the parameters. You shouldn't have to change the code in any of the default models. So make sure for all the modules you assign all the inputs. If you're not using an output, leave it empty, but don't try to take it out of the design. So once again, inputs, assign them values. If you're not using them, just some nondescript value that doesn't do anything. And then outputs, you can leave them empty. So there's a FSM template there. I don't ever write state machines from scratch. I start with a template. Certainly that's where you should start also. The Universal 7-segment display driver has everything you need to know in the header of the module. Take a look at that. And so this quarter I am going to emphasize, of course, testing this and simulating it yourself in hardware. It's going to get you through this class, I'll tell you that. I'm not going to always be there to help, as in a normal class. The simulator is going to be your friend. So there is a testing clock divider that I put in there that has an input that you can change where it just essentially bypasses the clock. The problem with testing this module is the display driver has a giant clock divider in it. That means you can't simulate it normally. So what you're going to do in the simulation is bypass that clock divider. Essentially, I gave that one clock divider module such that it's really easy to bypass that clock, and so essentially it doesn't slow the clock down. So the output of the 7-segment display driver is going to be wrong, but you can track essentially the output of the RAM to see if the RAM has the right values in it. And also in the simulator, you can actually just look at the values in the RAM. So our due date is the 13th, Monday, April 13th. Essentially, that's 1 week. I'm very flexible on due dates, but by all means, you want to get started on this. You don't want to fall behind. If you fall behind in this course, it's really hard to catch up, so please don't fall behind. Ask questions, send me email. Do what you need to do. I'm here to help. Give me a chance.